Hello everybody, so today we're going to be talking about physics, energy stores, and focusing on work done, kinetic energy, and gravitational potential energy. So these all are our energy stores. So we have multiple energy stores. We have 7 to be exact. So number 1 is our kinetic energy. Kinetic energy is increases as our speed of the object increases. It's based on the speed. So if the speed increases, so does the kinetic energy. Number 2 is our gravitational potential energy, which is increased as the height of an object from the ground is increased. So if we take a ball to Burj Khalifa, its gravitational potential energy is much higher than when it is on top of a 2-story building. Number 3, chemical energy. Chemical energy is basically the energy stored in fuel, food, batteries, wood, humans, plants, and animals. So this is it's like a basic one where it's even in food. So we get chemical energy from our food. Number 4 is elastic. It increases when the object is stretched, compressed, or bent. So if we take a rubber band and we pull, the more we pull, the more the elastic energy increases. Number 5 is the nuclear energy. In the nucleus of an atom, it's released during nuclear fission or fusion. Internal, which is thermal energy, is the total kinetic energy of the molecules of a substance increases when temperature of an object increases. It's due to the collision of the particles causing the thermal energy to go higher. Number 7 is the electrostatic and magnetic energy stores. These are energy stores stored in the electric field and magnetic field. So today we're going to be focusing on kinetic energy and gravitational energy and work done. So firstly, what is work done? So work done is a measure of how much energy is transferred when a force causes an object to move. Work done is when what you're aiming to do, like you're trying to push a box and to which location, and if you finish it, that's work done if the stationary object moves. So the formula is work done equals to force multiplied by distance, and it's measured in joules. And then we have gravitational potential energy, the formula. The formula is GPE is equal to the mass multiplied the gravity multiplied by the delta H, which is difference in height. Kinetic energy is KE equals to 1.5 of mv squared. M is the mass and V is the velocity, and half of that. Okay, so now we're going to go do some past paper questions. First question is, another person pushes the shopping trolley with a force of 40 newtons. The shopping trolley moves at a constant speed along a horizontal path. Calculate the work done by the 40 Newton force to move the shopping trolley a distance of 50 meters. So this is our work done formula, force multiplied by distance. We have the force, which is 40 newtons, and the distance of 50. So equals to 40 multiplied by 50. We get the answer of 20,000. And this, the measure of measure is of work done is joules, so we get 2000 joules. The work done on the shopping trolley as it starts moving is transferred into other energy stores. State 2 such energy stores. So as we're pushing the trolley, there's always a force opposing it, or when we're moving any object, there's always a force opposing it. It's called friction, and that friction is on the floor when we rub, and friction causes heat. So number 1, it's thermal energy due to the friction, thermal energy store. And number 2 is for a moving object. When an object moves, it's kinetic energy, because a moving object. So our next question, the car is lifted vertically 0.78 meters onto the recovery vehicle as shown in Fig 3.3. The weight of the car is 14,000 newtons. Calculate the minimum work done on the car in lifting it onto the recovery vehicle from the ground. Include the unit. So this is again work done. We have the force multiplied by the distance. So this is our force and this is our distance. So work done is equal to 14,000 multiplied by 0.78. Work done is equal to, so now we get 14,000 multiplied by 0.78, which is equal to 10,920 joules. We can keep it as this, or we can just change it into this simplification. We're just going to write 11,000 here and the unit, which is joules for work done. So our next question. A girl holds a rubber ball out of a window of a tall building. The mass of the ball is 0.2 kg. The ball is at rest 10 meters above the concrete path. Calculate the gravitational potential energy of the ball relative to the concrete path. Okay, so we already know that the gravitational potential energy formula is mg delta h. So now what is our mass, which is 0.2? So we get 0.2 multiplied by our height, which is our gravity first, which is gravity is always 9.8, and then we get our 10. We get, this is 10 is the height, this is the weight, or the gravitational potential, not the gravitational potential, the gravity, and this is our weight, 0.2 kg. So if we multiply this, we get 19.6, and JPE is always measured in joules because it's energy again, so joules, 19.6 joules, or we can just convert it into 20 joules. The girl releases the ball and it falls towards the path. The ball strikes the path and bounces vertically upwards. Figure 1.1 shows the ball falling towards the path. The speed of the ball immediately before it strikes the path is 14 meters per second. The speed of the ball immediately after it strikes the path is 12 meters per second. Calculate the kinetic energy of the ball immediately after it strikes the concrete path. So our kinetic energy is Ke is equal to 1.5 of mv square. So what is our mass? Our mass we have, which is from the question below above, 0.2. So we get 0.2 multiplied by our speed, which is 12. So 12, and then we square, and then it's divided by 2. So now 12 squared 0.2 multiply 144 divided by 2. So now we can use our calculator for 0.2 multiplied by 144 is equal to 28.8 divided by 2 is equal to 14.4. So we can just round this to 14, and the measure is joules. Number B. A wind turbine is used to generate electricity. The useful output from the turbine in 1 second is 6,000 joules. The kinetic energy of the wind hitting the turbine in 1 second is 11,000 joules. The velocity of the wind hitting the turbine is 6.3 meters per second. Show that the mass of air hitting turbine each second is known is approximately 550 kg. So Ke, this is the formula, 1.5 mv squared. Now we're going to add our known values, which we know. So first we know how much kinetic energy it is. It is 11,000 is equal to 1.5 of m 6.3 squared. So 11,000 is equal to 1.5 of m. Okay, so now we have this. So this is multiplied over here. So now we're going to bring it to this side and divide it. So 11,000 divided by 39.69 is equal to 1.5 of m. So now we can use our calculator. So we get 277.15 is equal to 1.5 of m. So now we're going to bring this to this side and change this into multiplication. So 277.15 multiplied by 2 is equal to m. So it's 554, which is approximately equal to 550 kg. So yeah, thank you everybody for